Hi, I'm Andrew Sengul, and today I'll be demonstrating Medley Interlisp, a software system that helped to pioneer interactive development and graphical user interfaces. Before getting started with that, I'll go over some of the history of Interlisp. Be advised this will be an abridged summary of the events. Interlisp's development involved hundreds of people at organizations around the world working over a span of decades, so a full history would take far longer than the time we have. With that said, let's get started. The roots of Interlisp go back to PDP-1 Lisp, developed at MIT for the DEC PDP-1 computer. This implementation became the basis of BBN Lisp, developed by Bolt, Beranek, and Newman, or BBN, in the late 1960s. BBN was a DARPA contractor based in Cambridge, Massachusetts, notable for developing the TCP protocol that underlies the Internet. BBN Lisp had some of the earliest interactive development tools. These features were inspired by the idea that people's time is more valuable than computer time, which back then was seen as a radical notion. In the early 1970s, some key BBN developers moved to Xerox's Palo Alto Research Center and brought their Lisp implementation with them. The Palo Alto Research Center, or PARC, is a key location in computing history, known as the birthplace of the modern graphical user interface. Window interfaces were first developed for Xerox's Alto computer, which was famously demonstrated to Steve Jobs and inspired the interfaces for the Apple Lisa and then the Macintosh. BBN Lisp was adopted by PARC in their efforts to streamline software development, and it then became a joint project between Xerox and BBN. To recognize the partnership between the two companies, the software was renamed Interlisp. At Xerox, Interlisp was extended with GUI functions and ported to run on Xerox's line of computers called the D machines. These were the successors of the Alto, each one with a name beginning with the letter D, including the Dolphin and the Dorado. Its developers built a set of interface primitives joined with Interlisp at a low level, enabling a degree of power and flexibility in graphical software development unlike anything that came before. The Interlisp versions released during this time were named after musical terms, like chorus, carol, and harmony, until the Medley release, which became the new product name. Despite their impressive research, Xerox was notably unsuccessful in finding a market for its computers and software. After its development at PARC, the Interlisp project was transferred to a unit within Xerox called Xerox AI Systems. The AI market was stricken by the so-called AI winter, and Interlisp development then moved to a company called Envos, and finally to a company called Venue that stopped operations in the 1990s. Medley Interlisp was revived in 2018 by Ron Kaplan and Nick Briggs for use in their work on natural language analysis and user interface design respectively. Since then, a team of developers has coalesced around the project, including many of the original PARC staff. Interlisp is now available under a free open source license, with its original code ported to modern computing platforms where you can experience its features firsthand. And with that said, let's dive in. And you are now looking at the Interlisp desktop. So for some background, I came to Interlisp without much more information than most of you have right now last year and started learning it from the ground up. So what you have here is not unfamiliar if you have ever used the original Mac OS. It's a display using binary color, so black and white pixels only. And I've got some experience in Common Lisp, but didn't quite prepare me for what I encountered when I got into this system. So from this starting point, we can right-click on the screen, and we see the equivalent of a start menu in Medley. So this allows me to choose some things. Let's get into the executables first. So here's an Interlisp window, and here's a Common Lisp window. So what exactly is going on here? Medley contains implementations of both Interlisp and Common Lisp. These are in fact the same binary. They simply use different packages and readers. So if we go over here to Common Lisp, we can see that things work more or less the way you would expect. And over here in Interlisp, that's all right. Whoa, what's this? List is an undefined function. That's better. One of the immediately apparent differences between them is that the Interlisp reader does not automatically upcase symbols like Common Lisp does, and most Lisp developers are familiar with. So, but these have more shared than you might expect. So let's make a variable now. And we can reference it here from the IL package, Interlisp. If we can see I've redefined one of the values I created over here on the Common Lisp side. It works as you'd expect. It works over here too. So these languages share many of the same data structures. Not everything is compatible though. For example, arrays are not compatible. If you want to use arrays from the Interlisp side and Common Lisp, you'll need to use the Interlisp functions to address them, and vice versa. But you can quite easily create blended applications using this language. So with that, with a little introduction to that, the way that moving things around doesn't work quite the way you might expect. You only see the frame of the object you're moving. Obviously, on those old computers, moving the window entirely would have been a little too hard on the processor. If I want to reshape a window, I'd do it this way. And interestingly, screenshots are a capability built into the system at the, it's right there in the start menu. So I can snap, move the window over here. Now I've got an image in a window of this thing I just screenshotted. But let's close that for now. Take a look at something else that was important enough to merit inclusion in this top-level menu. T-edit. So this is some kind of text editor, apparently. See, it's gotten, when I middle click on the bar here, it gives me this expanded menu. So what's this? Looks like this is a bit more than a text editor. It's actually an early word processor. So this was developed under the influence of the Alto Bravo system, which was the first WYSIWYG editor ever, and one of the key designers of which went on to found the Office division at Microsoft. So this has some shared lineage with basically word processors as a whole. But back in these days, the options were a little less complicated than the big ribbon menu you get on modern Office software. You have to choose your font and click apply. Then let's see about changing the size. Also, let's check out the italics. If it's already bold, you have to debold it by choosing this strike through bold. Now let's see about making it bigger. bigger, bigger. Let's make it 32 points. Oops, can't find the font Times Roman 32. So in the Medley system, these fonts are implemented as bitmaps. So each font is simply a set of images of each letter. They're not vectorized, so they only exist at certain fixed sizes. So with regards to size, you can't just have it your way. While this may seem quite crude compared to modern word processors, this is linked with an interactive software environment. So you can do things like there's a little book icon here. It's apparently been shrunken down from something bigger. Let's expand it and see what this is. This is the interactive documentation for the Medley system. So clicking around in here, I can learn about the different features of the language, data types, even things like creating the windows and menus. Got to have that uppercase. Gives me a blank window. And drawing to it isn't that hard, as we'll learn later on. And all of this documentation was created using the tedit text editor. And there's another software system that extends tedit called Note Cards. That is an early hypertext system for Medley, and which influenced HyperCard. Was some of the It was an example of some of the major pre-web hypertext systems. But all the features of the system are laid out for you right here. So the interface is a little unfamiliar. Mouse clicks don't do what you would expect based on your experience with any current operating system. But once you start to get used to it, it's a surprisingly consistent system and far faster to build windows and draw things on them than any modern graphical toolkit. So, having gained some experience with Medley, I wanted to try writing some kind of software for it. And questioning some of the developers, I found that they're at least in contemporary use, they haven't been doing much in the way of reading and writing graphics to files. So I decided I'd write my own file reader. Now, this will take us into this is basically going to take us into my current experiences with Medley and current experiments. So you'll get to reenact and experience some of these explorations with me. So I put some snippets of text here that were helpful to me. Let's close this. I need to set up a Xerox Common Lisp executable. Do some of these things. I'm going to create a new package called NetPBM. So using the Alt V key using Alt V will paste something from the host operating system clipboard. And there have been efforts by the developers to support as many modern operating systems as they can. So this will work with Linux, Windows, and Mac OS, varying levels of quality. The Linux integrations are quite good. So let's define a package for NetPBM. Then I'm just going to oh, right. Before I do that, I have to load the text modules. Looks like I'll need to consult some documentation on that. There we go. I needed to load that from Interlisp. So some of these faculties are in different namespaces. That one I need to do through Interlisp. So that pops up this file manager showing me that the text modules is loaded. In order to go back to repeat a prior entry, I type fix 58. That's the line number of that. I added a backslash there. Okay, so now we've got the NetPBM package installed. And what that contains is these pieces, these functions here. So let's open up that file manager. We see that NetPBM is newly added. I can look at its functions. And this is the sedit, the structure editor for this function. Let's read the whole thing. So this is a Lisp, a Lisp code editor. It specifically enforces some style conventions. So I can put my cursor here and type enter all I want, but it's not going to do anything unless I actually type parentheses. Once I delete that object, it closes things up the way you would like. And what this package that I've just loaded, it has files to load from PGM format bitmaps. So PGM is a very simple image format. Is a very inefficient image format. It has no compression whatsoever. It's just the raw bits on the disk expressing what pixels are in the image. So if I wanted to use something like if I want to use something like GIFs or PNG files, the way the faculties for those, like the way the COM Lisp libraries for those work, is to call out to C libraries to read them. So for this, I'm just going to use a simple format for now to store and express this data. But if I was to change this, I could just middle click here. I could select one of these options like done and compile, and then continue using my altered function. So preparing for this, I built some pixel graphics using some of my favorite tools. So those of you who've seen other talks from me or seen other things I've done, maybe familiar with my April language. Suffice it to say, it's a very efficient tool for pixel graphics. So what I did was I took this video game font, and because I don't have multiple colors like this font has, I created some 4x4 pixel megapixels that are basically composite pixels that express different shades using a gradient like this. And then what I generated was this text Interlisp. So let's see about loading that and displaying that in Medley. So I saved my text string that I need to display this. I can use Barry to send this to the back. And right there we have our window containing these this bitmap. And I was going to build an animated display of this, but I was running into some bugs. It's recursion, especially as you see here with this play slides, is a recursive function. So recursion especially is leading me into some out of memory problems. It's clearly not got the level of optimization of modern Lisps, but the another issue is that the original, so Medley originally did not have the CLTL1 features in it, or the CLTL2 features in it. Its common Lisp was only up to date as of CLTL1. In between CLTL1 and CLTL2, that's when the serious development to the environment stopped. So the development team has been working to add back in the CLTL2 features. For instance, a loop and many of its features are now in Medley when they weren't last year. So even since I've been working on it, there have been updates. So I'm going to check into that to later to get that working. But for now, this gives you an idea some of the trials I've encountered in the course of making things work on this system. But the speed with which I was able to do this was remarkable. So clearly, I was more comfortable editing this code in Emacs than in Interlisp to begin with. And all I needed to do to load it was to do this tm load text module. You load a Lisp file in, you choose a package for it, and it's loaded into that package. And a couple other fun things. Those of you who took a look at my paper in the proceedings, you may have noticed that there was on the cover illustration, there's a clock. And it's this, the by clock. You can drag it around, pops up a clock, and you can supersize it. So unlike the letters, this is a vector-driven object. It draws these numbers at any size you like, hence the waiting period to see it when you draw a big clock. Wow. Windows are fighting over which is going to display on top. And further, if you're ever curious about one of these functions, there's a manual page system which you can call up like this. Let's look into the buttons library. Has some documentation of these button features. I'll load buttons into the files. And when I do, it produces a button, which I can use to create another button and create another button. And right-clicking on it allows me to customize its actions. So Anything evaluated you can put in here, and that action will be done when you click the button. And then speaking of bitmaps, this window here, all right, well, just to summarize, you can view a bitmap by you can also right-click to view a bitmap, but that's best explored later. So for anyone who has questions, I welcome those in the chat.
Can I ask if Anders Hoff, the next presenter, you're here? Okay, cool.
Yeah, anyone in the audience got questions? Yes. Okay, whether it runs in an emulator. I guess I'll relay that. I do. Any other questions while we're waiting for an answer? Yes. Of what? Spaghetti sacks? Okay.
Yes, I see. Does it run in? Oh, yes, good question. The Medley uses an emulator called Mako. So Mako emulates the hardware, the stack machine-based hardware of the D machines. Mako was actually written back in the 90s or 80s or 90s by Fuji Xerox in Japan. So they wanted the system to run on some of the PC-compatible hardware that they were using at the time. And so the emulator has been an ongoing effort since then. And does it have the full implementation of spaghetti stacks? That I'm not certain of. I know that I think that some of the other team members are going to be in the chat, and they could answer that. And I see, is there something practical I can use Medley Interlisp for? Does the word actually support different sizes of text in one document? Yes. You can point at, you point at a line, you change the font, you change the size, point another line, change that size. So you can have all kinds of different fonts and sizes in a document. So as for practical uses, we've been considering things like embedded applications. It's notable that Medley it's a stack machine implementation, and most of the stack machines that I know of that are at all current now are extremely simple forth implementations for tiny embedded devices. But Medley is an extremely efficient software implementation with a full-featured graphical environment. So if you wanted to use something like an e-ink screen on an Arduino, it may be that there's a sweet spot for it with a use case like that.
All right, let's thank the speaker once again.
Thanks, everyone.